So I forgot to record. So here we are at lunchtime recording lesson 5.4. Probably would help if you could see what's going on. So lesson 5.4. We are talking about verifying differential equations. This is our last lesson. So test is Wednesday. Tomorrow we will be doing a challenge. So the homework that is assigned will be due on Friday. So Friday we will also start reviewing for the test. Like I said, test on Wednesday. So verifying differential equations is a little bit different. Aiden asked during our lesson today, is this like a precursor to something else that we're doing? And it's not. So sometimes we want to know if something that we already have is a solution to a given differential equation. Okay, so I'm going to give you an example, and then I'm going to tell you how we do these things. Okay, so here's an example. It would say f prime of x is equal to 3 f of x over x natural log x. Is f of x equals 2 natural log x cubed a solution to the given differential equation? Okay, I'm not going to write out the word differential. So this guy over here kind of acts like a recipe. So what we have to do is we manipulate our given equation, which would be this guy, this f of x, our given y, so original equation, to plug into the y prime equation. Okay, we manipulate our given y to plug into the y prime equation. So this says that I need f prime of x. The confusion when I did this in class was they were like, this says it's f prime of x. We want to see, that's true, but we want to see if this is also equal to that. So we're going to come over here, and this tells me I need f prime and f of x. I have f of x. I need f prime, f prime, f prime. So over here, f prime is equal to derivative, and I know that's weird because we've been doing integrals. So 6 natural log of x squared, don't forget the chain rule. So times the derivative of natural log, which is 1 over x. That is f prime. When I rewrite him, I'm going to write him as one fraction, okay? So f prime of this is 6 natural log of x squared over x. We want to know, is this equal to 3 times f of x, oops, over x times natural log of x. So this is 6 natural log of x squared over x. When I simplify this, this is 6. That's a good sign. Natural log of x cubed over x natural log x. So I've got the 6 in the x. I've got the 6 over the in the x. This, sorry, 6 over x, 6 over x. This reduces here. I've got a natural log x on the bottom and 3 of them on the top. So I can cancel, and that gives me 2. This is equal to 6 natural log of x squared over x, which is the same as this. So I know then that this equation satisfies this differential equation. So the answer is yes. That's all you got to do. So it's derivative. You'll have to do some derivatives, and it's algebra. So once you get here, other than doing the derivative, you're just plugging in and algebraing this out to see if it works or not. So it's kind of like a proof. Caleb said that in class. It's kind of like a proof. This is just what you are working on to using as your kind of template to plug the things into. You're setting up your proof and you're going from here. Are these two things equal? So this is to help you set it up. This is the actual proof. Okay, so let me show you another one. So today we have dy dx is equal to x plus 4y minus 2. And the equation is y equals negative 1/4 x. That's a negative plus 3/4. And I want to know, is this a solution? Okay, so this is my template. So I'm going to manipulate this guy and plug him into this template. So this tells me I need y prime, which is this. Okay, dy dx of y prime. So y prime is, this is a linear thing. The derivative is negative 1/4. Negative 1/4 x plus 4, negative 1/4 x plus 3/4 minus 2. Okay, now it's all just math. I mean, it's all math, but now it's all just algebra math. Okay, so we're going to distribute here. So this is x plus 4 times negative 1/4 is negative 1. 4 times 3/4, that is 12/4, or 3, minus 2. When I simplify, the x's cancel, and I have 3 minus 2, that's 1. These are not equal. So this is not a solution. Okay, so let me show you another one. I'm going to show you two more. So this one says y prime is equal to x times y squared. And so the question is y equals 2/9 plus x squared a solution? Y prime, so I come over here and I do the derivative of this, which you should probably use the quotient rule. Or you can move your 9 plus x squared up, but it's easier to use the quotient rule on this one. So y prime, derivative of 2 is 0 times the bottom minus the top. The derivative of the bottom is 2x over the bottom squared. So this is negative 4x over 9 plus x squared squared. There's your derivative. So that's y prime. So negative 4x over 9 plus x squared squared equals, this says x times y squared. So x, here's y. So I'm going to do 2/9 plus x squared squared. Now, remember, this is where the algebra comes in, and remembering all these things. Like, you have to square, when you square a fraction, you square the top and you square the bottom. So 2 squared is 4. That leaves me with 4x here. And the bottom squared is the bottom squared, right? Don't do anything. Also, you can kind of look over here and be like, those are the same. But now, are they the same? The question is, you're comparing those, and the answer is no, because this one's negative and this one's positive. So close, but no. Okay, last one. So we've got g prime of x is equal to 3x over 4g of x. Is g of x equals square root 3x squared over 2 a solution? Now, we got to have g prime. Got to have g. I got g. I need g prime. So I would say, if you're going to be efficient about finding your g prime, rewrite this guy. We're dividing by 2. That's the same as multiplying by 1/2. We've got 3x squared to the 1/2 power. So g prime of x. Don't forget, like, power comes down. So 1/4 3x squared to the negative 1/2. Don't forget chain rule. So times 6x. Okay, I'm going to simplify that a little bit. I'm going to send him to the bottom because he's negative. 6x on the top, 4 on the bottom. So this is 3x squared to the 1/2. There's my g prime. And I think I'm also going to reduce these, okay? That's 6/4. So this is 3x over 2, 3x squared to the 1/2. Okay, so 3x over 4, and now g of x goes there. So square root 3x squared over 2. Now I cheated and made that over 2, but it's all over 2. So look at this simplification right here. That's a 4 divided by 2. 4 divided by 2 is 2. So square root, 4 divided by whatever, that's 2. Square root 3x squared. This is the square root of 3x squared. So these two things are the same. Therefore, the answer is yes. There you go. That is what we learned on Wednesday. Now, on your homework. Okay. So, let's see. David has his. Joe, yours is here. Or I can maybe post it to Facebook, whatever. That is not Facebook, Google Classroom. Okay. So same thing. It's just reversed here. So here's the differential equation. Here's your f of x. So instead of me writing the differential equation first, I wrote the equation first. So you're still manipulating f of x to fit into here. So these guys are yes, no questions, just like we did in the notes. These 4 are verified. That means it has to work. It has to work, but you just have to show that it works. Now, a little bit of weirdness here. We've been doing the plus C and the C that absorbs everything. This is different. Okay, so we've got a C here and a C here. These C's do not absorb everything. This is a constant. It's just there along for the ride. So for example, the derivative of this is not 2x. It's not 2x. Okay, the derivative of this guy right here, this piece of it, is 2cx, because we don't, C is a set number. We just don't know what it is. So there's a difference between the C that we were doing in our separable differential equations in this. So the derivative of this is 2cx, because the derivative would be 2 multiplied by this, but I don't know what this is. So 2cx. This guy, his derivative is C. So when you're working with those, just be careful. Those are a little weird. These will be like just verify, just have to show the work. They should work out. If they don't work out, you made a mistake. 8 to 10 and 11 to 13 are a little bit different. I give you one differential equation, and then you're checking each of these in it. Okay, so differential equations, we haven't seen this notation in a while either. So this is fourth derivative, the fourth derivative of y. So this little y to the fourth dealie here. Fourth derivative of y minus 16y equals 0. So you're checking each of these 3 to see which ones are solutions. So it'll be yeses and nos. And same thing here, the difference is I just switched the equations on you. Okay, so same thing. Gold Star Club, I said you could get rid of 2 and 4 and 6. 2, 4, and 6 you may get rid of if you're at Gold Star Club. Okay, that was fast. So if you try this and you're like, I can't do it, come and get help.